So right at the end of section 4.2, we introduced this concept of variation. So variation is how widely our data set is spread out around our mean. The closer our data gathers towards the mean, the less variation. The further it spreads out away from our mean, the greater variation. So here's our book and course learning objective. Let's talk about range. Range, the range of a data set, is the difference between its highest and lowest value. So let's consider the following two sets of quiz scores. Which has the greater range? So let's calculate range for quiz 1. Well, that's my maximum value, which is 10, minus my minimum value, which is 1. So we have a range of 9. For quiz 2, I have a maximum value of 10 and a minimum of 2, so I get 8. So which quiz has the greater range, the widest spread out? Well, that's going to be quiz 1. But would we also say that that set has the greatest variation in differing away from our measure of center? No. Quiz 2 has greater variation because it has more possible values distributed out. So let's introduce a few more definitions. So the lower quartile, or first quartile, Q1, divides the lowest fourth of the data set from the upper 3/4. So this is the median of the lower half, which is also sometimes called like the 25th percentile. That means, and we're going to talk about that, but that means that 25% of the data is less than Q1. The median quartile, also known as the median, this is also called the second quartile or the 50th percentile, meaning 50% of data is less than the median, and that makes sense, right? Because the median is the middle value. It's what divides our data set in half. The upper quartile, third quartile, or Q3, think of quarters, like 25 cents, 50 cents, 3/4 would give you 75 cents. That's the 75th percentile, meaning that 75% of data is lower than that data value. And it separates the lowest 3/4 of the data from the upper quarter of the data. This is the median of the upper half of the data set. So quartiles in the 5-number summary, that's something we use to make box plots. So the 5-number summary contains the minimum value, the maximum value, Q1, Q2, which is the median, and Q3. So let's go ahead and take a look at some waiting times for banks. So we took all possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we took 11 waiting times from each bank. We sorted this data, so we ordered it from smallest to largest. We then found our median value, which happened to be 72.2 for both of them. And then in order to find Q1 and Q2, we took the median of the lower half. So since we had 5 data values left, we took the middle one. And we took the median of the upper half. So since we had 5 data values on each side, we took the upper one, the middle one. So here's the 5-number summary. We take our lowest value, Q1, Q2, Q3, and our maximum value. So if we were given some waiting times for banks, the banks we had looked at the entire data set in the previous slide, here would be our 5-number summary. A box plot is a graph that displays data using the 5-number summary, and you need to make sure that this is all graphed on a number line. Number line, that way we can compare box plots. So let's draw a box plot. So the first thing you do is you draw a number line that spans all the values in the data set. You enclose the values from the lower Q1 to the lower Q3 in a box, and you draw a line through the box at the median, which is also Q2. You then add quote-unquote whiskers. This is sometimes also called like a box and whisker plot. Maybe you've heard of that before. Extending to our low and highest values, so our minimum and our maximum. So let's go ahead and make two box plots for this data set. So here's our waiting times for banks. The first thing we're going to do is we're going to draw a number line that encompasses all of this data. So we've got 4, 5, 6, 7, 8, 9, 10, 11, and I tried my best to keep those evenly spaced out, but I guess I failed. So let's go ahead and green and graph the big blank. So I've got an outlier at 4.1, so it's minimum, a high at 11. Ooh, this is really spread out. Its lower quartile is at 5.6. Its upper quartile is at 8.5. We connect that with a box. We put a vertical line at our median. That's Q2, Q1, Q3. And let's go ahead and label our max and our minimum. So here's my beautiful box plot for Big Bank. Let's go ahead and use orange to graph the best bank. So my lowest value is 6.6. I'm going to graph these on the same number line. So I've got 6.6. Maybe I'll move that up a little bit so we can see it better. I've got 6.6. My maximum value is 7.8. Oh wow, that's a lot smaller of a range, right? Range meaning the largest minus the smallest. My median is 7.2, which was the same as Big Bank. My upper quartile is 7.7, which is really close to my max. Again, draw as best as you can. And my Q1 is 6.7. So, which of these two banks has larger variation? Well, Big Bank has larger variation because I could wait anywhere between 4 minutes and 11 minutes. My best bank has smallest variation, so even though I could wait anywhere between 6.6 and 7.8 minutes, that'd probably be the best place to go because there's less variation.